In this video, we are going to discuss about the concept of storage classes in C. So, storage classes, these are something that is confined, or that is something inclined towards the concept of variables. So, normally when we try to declare a variable, we declare the variable with a data type. But it also means that there is also a storage class that is available for a particular variable. So, along with the data type, the declaration of a variable also indicates about the storage class. So what do you mean by a storage class? So basically, we know that from a compiler point of view, every time when we try to give a variable name, it identifies some physical location for your variable. So there is some kind of memory space that has been allotted for your variable whenever we are trying to declare a variable, and this particular variable memory location will have the value that is getting represented in terms of bits, in terms of zeros and ones. So basically there are two kinds of location in your computer. So one is your memory, the other one is the CPU registers. Okay, so basically these are the two kinds of memory locations in your computer where your value will be stored. So whenever we are trying to declare a variable, it is essential to specify the storage class as well. So what happens if we are not going to specify the storage class? Why? Because we normally, when we try to declare a variable, we give the data type of the variable and then the variable name. But what I told you some time back is that when we try to declare a variable, it indicates about the data type as well as the storage class. So if you are not specifying the storage class, then what happens is your compiler will try to take the default storage class in that particular context. So in that particular context, whatever your compiler is going to process at that point of time, it will try to allocate the default storage class in the context in which your compiler is going to refer. So first we will see what your storage class is going to talk about. So first and foremost thing is your storage class tells where your variable should be stored. Okay, so where your variable should be stored, whether it should be stored in your memory or it should be stored in your CPU register. And it also tells about what is the initial value of the particular variable. So initial value in the sense, it talks about the default value that you are going to give for your variable. So normally when we try to go for the declaration, let's say for example, I'm simply giving the declaration statement like this, variable x in terms of an integer. So the value is not assigned for this particular variable, but there will be some default value or there will be some initial value whenever this particular variable has been declared. So your storage class is going to tell what will be the initial value or default value for the variables that you are trying to store. And also it speaks about what is the scope of your variable. So scope of the variable in the sense, what is the lifetime of your variable. So we used to declare some variables within a specific block of code. So that particular variable's lifetime lies only within that particular block of code. So let's say for example functions, especially when we try to write some function definition, inside that function definition we used to declare some variables, and those variables are having a lifetime only within that particular functions. So your storage class is going to tell about what is the scope of your variable as well, and of course as I told you, it will tell you what is the life of your variable. So these are the four things that the storage class is going to tell about. So basically first it tells where your variable should be stored, whether it is in the memory or the CPU register, what will be the initial value of your variable, what is the scope and lifetime of your variable. So these are the things that your storage class is going to tell. Now we are going to see the different types of storage classes. There are actually four types of storage classes. The first one is the automatic storage class. The second one is register storage class, and the third one is static storage class, and the fourth one is the external storage class. So these are the four storage classes that are available in your C programming. So automatic, register, static, and external. So we will see these storage classes one after the other. So first I'm going to discuss about the automatic storage class. So automatic storage class, basically there are certain features that are available when you are trying to declare a variable as a automatic storage class. So for example, the variables that are declared as automatic Okay, so the keyword that we are going to use to declare a variable as an automatic is auto. So whenever in our normal programming language, in our normal piece of code, what we do is we used to simply declare the variables, or we used to simply assign some variable during the declaration. So by default, all these variables will be identified as an auto storage class. So basically what happens is the storage device in which your in which your auto variables are going to get stored is your main memory. Okay, so the storage device is going to be your main memory, and this particular variable that has been declared as auto. So whether you give the keyword that is auto, or if you are not going to give the keyword auto and you are just going to simply declare the variable and assign some value, by default the values are going to get stored in your memory. By default the values are going to get stored in your memory. So basically the default value for variables that are being stored in the automatic storage classes, it will have a default value of a garbage value. So garbage value is something that is unpredictable, or it is not, it's an abnormal value that is getting assigned to the variables that are declared as auto. So what is the scope of the auto variables? So if you see the scope of the particular auto variable, it has been local to the particular block. So local to the particular code block where you are going to use this particular variable. So within the code block, if you are trying to declare a variable as an auto, then it means that the scope of the particular variable lies only within that code block. And what will be the lifetime of this particular variable? So if you see the lifetime of the variable, let's say for example, it is going to have the control till the block, within the particular block in which the variable is going to be defined. So the control remains within the block. Control remains within the block where the variable has been declared. So control remains within the block where the variable has been declared. So we'll see a simple example, and that will give you a very clarity idea. So let's say for example, I'm just declaring my preprocessor directives, stdio.h, coneo.h. So let's say for example, I'm declaring my main function, and here I give so first let us see what happens if you are not going to give the keyword that is auto. So let's say for example, a value equal to 10 and a value and a b value. So clear screen. I'm just trying to simply print the values of a and b. So %d/t, %d, and I'm just giving some values. I'm just simply printing the values. So here if you see this particular piece of block, what I have done is I have just declared the variables a and b. I've just declared the variables a and b, and I'm trying to print the values of a and b. I'm trying to print the values of a and b. So what happens here is there is no value that is getting assigned for the variable a and b. So whenever we are trying to declare the variables only with the data type, it just means that the values will be stored in the memory. So basically these variables are of auto type. So if I run this piece of code, you can see you are able to get some garbage value. You are able to get some garbage value. So this is an unpredictable value. Okay. So it may be it differs time to time. So what happens here is we have not assigned any value for the variables. Okay, but we are trying to print its value. We are just trying to print its value, and when we try to print these particular values, what happens here is we are able to get the garbage value. So we are able to get the garbage value. So the garbage value, always remember, these are unpredictable values. These are unpredictable values. So let's say for example, now what I'm going to do is I'm just going to print the values. So after assigning some values for a and b, so a value equal to 10 and b value equal to 20, b. So I'm trying to print the values of a and b now. So I'm just trying to print the values of a and b. So you can see that the values of a and b are printed, and even the garbage value keeps on changing. So it's an unpredictable value. So every time it keeps on changing. Now, if I'm trying to add the keyword that is auto, so it means that the storage class is going to be your main memory. So these variables are by default, it is going to get stored in your main memory. So first time I'm just going for the declaration, and you can see that the garbage value remains the same. So it's an unpredictable value, and after I'm trying to assign the values of A and B in that particular variables, then the value is getting printed. So whenever you are trying to declare a variable and print its value, okay, so by default your compiler will consider that particular variable as a auto variables, that is the storage class for these particular variables lies in the memory, and it will try to print the garbage value before the value is getting assigned. So next we are going to see about the second storage class, that is your static. We will go for the register classes. Okay, register. So when it comes to the register class, okay, so when it comes to the register class, what happens here is the features of the variable that is defined in your register storage class. Okay, so first and foremost thing is we are going to make use of the keyword that is register. Okay, so the keyword that we are going to use is register, and if you see the storage device for this particular variables that are being identified with register, so the storage device is going to be your CPU registers. The storage device is going to be your CPU registers, and of course the default value for the variables that are being given as a register, so the default value will be again a garbage value. So the garbage value, as I told you, it is an unpredictable value. So every variable that has been declared with the keyword that is register, it will have a default value that is the garbage value. So again, if you see the scope and life of the particular variable, it remains the same as your variable that has been declared with the keyword that is auto. So the scope and lifetime, okay, it remains the same as what we saw for the auto storage classes. Okay, so the scope of the variable lies local within to the code block in which the variable has been defined, and if you see the lifetime of that particular variable, its life continues till the control remains within the block in which the variable has been declared and defined. So here what I'm doing is, let me say for example, okay, let me just comment out these scopes. Okay, so I just commented the previous set of codes. Now what I'm going to do is I'm just going to declare a variable in terms of register. Okay, so I've declared a variable x, and I've declared that particular variable x of integer data type, and I've specified the storage class as register with the keyword register. The keyword register. So now what I'm going to do is I'm just trying to print the value of register. See, print the value of x. So let's say for example %d and x. Okay, so you can see some garbage value for the value that is x. Now what I'm going to do is I'm just going to make use of value declaration. Let's say for example x value is equal to 0, and I'm just trying to create a while loop where I check the condition x is less than 5, and I'm trying to print the value of x. %d/t x, and I'm trying to increment the value of x. So you can see the x value is getting assigned to 0, and it keeps on incrementing by 1. So the value is being stored in a CPU register, and always remember the value that gets stored in your CPU register can be always accessed faster when compared to the value that is stored in the memory. So if you have a variable that is being used in many areas in your program, so it is always better to declare your storage class as a register for that particular variable. So one good example is when you are trying to use the variables for the looping, you can make use of the looping variables as a register variable, so that it is very easy and fast to access the value when compared to the value that has been stored in your memory. So, and one more thing, always remember, if your microprocessor has 16-bit register, then they cannot hold a float or a double value, which requires 4 and 8 bytes respectively. So if you use the register storage class for float or a double variable, you will not get any error message. but the compiler will treat the variables of a auto storage class. So next we are going to see about the concept of static storage class. So we are going to discuss about the concept of the static storage class. So the keyword that we are going to make use to declare a variable storage class of static is this keyword is a static. Okay, so we are going to make use of the keyword that is static in order to identify the variable storage class as static. So what happens here is again, when we go for the static storage class, here we are going to make use of the storage device as your memory. So let's say for example, here I have a example. Let me say I will declare a variable. I declare a variable D with the keyword that is static. So it means that the storage will happen. The value of that particular variable will be stored in your memory, and the default value of a variable that has been stored with the keyword static will be always 0. It will be always 0, and when compared to the scope, okay, the scope remains the same. The scope of your variable that has been declared with the keyword that is static is going to be local to the code block, but there is a slight difference in the lifetime of the variable. So remember, for a variable that has been declared as a static, the value of the variable is going to remain the same. The value of the variable is going to remain the same. This value remains the same between various function calls. So we'll see an example that can easily makes you understand about the concept of static variables. So here what I'm going to do is, again, I'm just going to comment out this piece of code. Okay, so let's say for example, I have declared a variable, okay, static int c. Okay, so static int c, and I'm trying to print the value of c now. So you can see that c has got the default value that is 0. But we need to understand only one thing, that is how the value of the variable remains the same between the various function calls or outside the function. So here what I'm going to do is I'm just going to okay, so let us say for example I create a function change static, and I'm going to take one more example for auto. So let's say for example change auto. So in both these functions I'm going to make use of the static variable as well as a variable that is stored in the memory, that is a variable that has been using the auto storage class, okay, for the respective functions. So what I'm doing is I'm just going to call my main function. So I've declared a static integer variable that is c, so which means this variable will be stored in the memory location, and it will have the default value that is 0. And what I'm going to do is I'm just going to call the functions. So here let's say for example okay, I'm just creating one more variable, so x value equal to 1, and I'm just going to make use of a while loop, okay, or a for loop. X value equal to 1 and x is less than or equal to 3, and I'm just going to increment the x value. And within this for loop I'm just going to call the functions. So first let's say for example I'm going to call the function that is, so first I'm going to call the function that is change auto, and then I'm going to call the function okay, so first I'm going to call the function change auto, and I'm repeating this particular piece of code for calling the function that is change static. Okay, so both these functions has to be called 3 times. And now what I'm going to do is in my function change auto, I'm going to declare a variable that is of auto storage class. So let's say for example number. Okay, so the value of that particular number is going to be 100, and I'm just trying to print the value of 100. I'm just going to print the value of number. So just calling the variable, and let's say for example I'm trying to make some changes to this variable. So number is equal to number into 5, just to show you the difference between the variable that is being stored under auto storage class and then the static storage class. So I'm just going to copy paste the same piece of code for the function that is change static. And I'm declaring this variable as a static variable. Okay, so let me tell you what is going to be the difference. So first time the function change auto is getting called, you have a variable inside the function definition that is number, which has been stored under the auto storage class. So the value of 100 will be printed. The value of 100 will be printed, and what happens is your value is getting updated to 500. That is, your value of 100 is getting multiplied by 5, and the value becomes 500. So at the end of this particular function, the value of number changes to 500. Now what happens again? The function call happens because the x value is getting incremented. Okay, so x value is getting incremented. So what happens is the function is again getting called, and when the function is again getting called, remember your number value will be again reinitialized to 100. Your number value will be again reinitialized to 100. Okay, so the value of 100 will be printed. Again the value of 100 is getting multiplied by 5, so the number value is getting updated to 500. So again the function call happens. Why? Because x value is getting incremented to 3, and once the function call happens, you can see that again the number value is getting assigned to 100, and the same 100 value will be printed, and the value of number is getting multiplied by 5, so the number value becomes 500. But always remember, whenever the function call is going to happen, the variable value will be only 100. Okay, at the beginning. So whatever value has been assigned at the beginning, okay, the same value will be used. Okay, whenever it is trying to get printed in this particular scenario. So remember, during the function call, whatever happens, okay, the value will not going to change. The value is not going to change. That is, it is not going to take the previous value. It is not going to take the previous value, which is not the case in terms of the static. Which is not the term in terms of a static. Okay, so if I run this particular piece of code, so you can see that the first three output statements, that is number, 100. Okay, so as I discussed, it comes as a change of your variable that has been stored in terms of the auto storage class. But when it comes to static, what happens is the number value whatever it got stored in the previous as a result of the previous outcome, so it is not going to be reinitialized. What happens is it is initialized to 100 only once. The value of number is going to be initialized, okay, only once as 100. Okay, so it will be initialized to 100 only once, so it is never getting initialized again. Okay, so during the first call of the function, it is getting multiplied by 5. It is getting multiplied by 5, so it has got the value that is 500. Okay, and during the second call, what happens is when the old value of 500 will be again multiplied, okay, again multiplied by 5, so that you will get the result that is 2500. Okay, so That is what happens. So during the third time, what happens is the value of 2500 gets printed. So first time the value of 100 is getting printed, second time the value of 500 is getting printed, and third time you can see the value of 2500 is getting printed. Okay, so this is one of the basic difference between the static storage class and then the auto storage class. So whenever you have the auto storage class, you should always remember, even though the control comes back to the same function, the auto variables, okay, I mean the variables that have the automatic storage class, okay, so it will take the existing value, okay, but when it comes to the variables that are taken as the static, I mean the variables that are having the static variables, okay, they have the same values that they had during the last time. Okay, so that's one of the major difference between auto and static. So next we are going to see about the external storage class. The last storage class is the external storage class. So we are going to see about the external storage class. So the keyword that we are going to make use is the extern. To declare a variable of external storage class, we have to make use of the keyword that is extern, and this particular variable values will be stored in your main memory. Okay, so the storage device is going to be your memory, and it will have the default value that is 0, similar to a static. Okay, so it will have the default value as 0, and when it comes to the scope of the particular variable that has been declared as external, okay, the scope of the variable is global. It is global, and if you see the lifetime, okay, so if you see the lifetime, this particular variable, okay, it continues as long as the program is getting executed. As long as the program is getting executed. So it has got no end, or it has got no termination. It has got no termination. Okay, so this is something about features of the external storage class. So external variables differ from whatever variables that we have discussed so far. Okay, their scope is global, it is not local. Okay, so basically your external variables are declared outside your functions. Okay, outside your functions, and they are available to all the functions that can make use of it. Okay, so here let's say for example I'm declaring a function. I'm declaring a variable intf. I'm declaring a variable intf. So I'm just trying to change extern, and I'm writing one more function, change extern 1. Okay, so I'm trying to print the value of I'm trying to print the value of f here. So I'm just trying to first print the value of f. So basically it will have a default value that is 0. It will have a default value that is 0. And what happens is I'm trying to call the function that is change extern. So here let's say for example I'm running the loop for twice, and I'm just trying to call the function that is change extern. So the same applies here. I'm trying to call the function change extern 1. So in my change extern, what I'm going to do is I'm just trying to multiply the value. I'm just trying to increment the value by 2. So let's say for example I have the f value, so f value is getting incremented by 2. So I'm just printing the f value. F value plus 2. So since f has been declared as an external variable, that has been, so whatever variable that you are trying to declare outside your functions, that will be identified as a global variable. So it is explicitly, it means that this particular variable is of external storage class. So f can be used anywhere by any function. So I'm just trying to print the value of f. So here f value gets incremented by 2 times. Okay, so now what happens is I'm just going to make one more change. change extern 1. So here okay, so I'm just trying to decrement the value of f by 1. I'm just trying to decrement the value of f by 1. So we'll have f value minus 1 percentage d. Okay, f value minus 1. So okay, so when I try to run this piece of code, what happens? So you have got the f value, the default value will be 0. You will have the default value that will be 0. So now x value in the loop, it takes a value of 1. So it is trying to call the function that is change extern. Okay, so change extern, we are trying to increment the value of f by 2. So f has initially got a value that is 0. So it is getting incremented by 2. So the value becomes 2. And what happens is you are just going to print the value that is 2 here. It is going to print the value that is 2 here. Okay, so now again x value becomes 2 here. Okay, so 2 is less than or equal to 2, the condition is true, and again you are calling the function. Now remember, your f value has got the value that is 2. It has got the value that is 2. So 2 is getting incremented by 2. So we'll be getting the value that is 4. So 4 will be printed in the next line. 4 will be printed in the next line. Now what happens is, again you are going to, so the loop ends because the condition is going to fail. When x value is going to be 3, the condition will fail. So you are again coming to the next piece of code block. Okay, so where your x value is equal to 1, and you are going to call the function change extern 1. So when you call the function change extern 1, you have got the f value equal to 4. Remember, f is a global variable, so f value has got the value that is 4. So 4 minus 1 value will be 3. So 3 will be printed here. Okay, so 3 will be printed here. And again you go to the for loop. Okay, so x value becomes 2 here. X value is 2 here. And what happens here is you are again calling the function change extern 1. So your f value has got the value that is 3. So 3 is getting decremented by 1. So we'll have the value 2. So it will print the value that is 2. So when I'm trying to run this piece of code, okay, I have declared. Okay, fine. I will declare the variable x. Okay, so as I told you, we can see the f value. Initially, the default value is 0. So I tried incrementing the value of f by 2 times. So 0 plus 2 became 2. And again, we call the function. So 2 plus 2 became 4. And we call the second function where f value was 4 and it was decremented by 1. So the value became 3. And again, when we try to run the last loop, the f value was 3 and it got decremented by 2. It got decremented by 1. So the value becomes 2. So whatever we have seen in this particular piece of code, it is getting executed. So we got the output 0, 2, 4 and then 3 and 2. Okay, so these are some of the concepts of the storage classes. Okay, so which will be helpful to learn about the memory allocation in the forthcoming sessions. So pretty lengthy video, but watch this video again carefully. So if you have any queries related to this particular video, you can post your questions in the comment section. I thank you for watching this particular video. Thank you.